The story of our world begins in the silent, swirling dust of a dying star's neighborhood. We gaze at the blue marble today, yet its true biological and geological genesis remains a deep mystery.
For decades, the standard model of asteroid accretion seemed to provide all the answers we required. Recent discoveries have shattered this confidence, revealing chemical signatures that no simple mixture of space rocks can explain. Is it possible that the very foundations of our planetary birth must be completely rewritten from scratch?
New simulations suggest a more violent, chaotic pathway involving massive planetary seeds scattered by moving gas giants. We are now exploring theories that link the quantum realm directly to the formation of continents and oceans. The latest research even questions if our entire universe began within the crushing gravity of a black hole. We must look deeper into the chemical isotopes and gravitational interactions that define our current reality. The silence of the primordial nebula hides the chaotic forces that forged the ground beneath our feet. Our existence is the result of a sequence of events we are only now starting to decode. The primary challenge lies in the missing pieces of Earth's volatile chemical puzzle. If we formed from contritic asteroids, our planet should be much richer in light elements like hydrogen. No known combination of these space rocks produces the exact elemental ratios we observe in the crust. Earth is far poorer in volatile components like helium than the standard astrophysical theories would ever predict. Scientists once blamed the extreme heat of early collisions for vaporizing these essential lighter elements. However, heat would have primarily vaporized the lighter isotopes of these elements, which have fewer neutrons. Recent experimental work has shown that these light isotopes are still present in their original ratios. This contradiction forces us to ask how a planet could lose volatile elements without losing their isotopes. The math simply does not add up when using the traditional accretion models of the mid-20th century. We are left staring at a chemical discrepancy that defies the standard narrative of our rocky home. If the rocks that stuck together were simple chondrites, our atmosphere would be unrecognizable today. We have been building our planetary history on a foundation of rocks that do not actually fit. This inexplicable discrepancy suggests that the prevailing theory of planetology requires a massive and fundamental update. We are essentially tracing the ghost of a planet that never quite matched the standard model we were taught. Perhaps we should stop viewing Earth as a random pile of space rubble that slowly stuck together. Instead, we must consider a dynamic model where the building blocks were already differentiated into cores. This shift in perspective allows us to integrate the gravitational dance of Jupiter into the terrestrial story. We need to look at the grand tack scenario as a primary driver of our elemental makeup. If Earth formed from a diverse mixture of large planetesimals, the chemical oddities finally begin to fade. This reframe moves us from passive accumulation to a chaotic, statistical outcome of a crowded solar system. It suggests that Earth's birth was not an accident, but a statistically likely result of physics. The history of our world is written in the language of kilometer-sized seeds and moving gas giants. We are looking at a process that is far more organized and predictable than we ever believed.